Here is the problem statement, and it says that we have been given n balloons, each with a number of coins associated with it. Okay, on bursting a balloon I, the number of coins gained is equal to this much. Okay, also balloons I minus 1 and I plus 1 now become adjacent. Okay, so the problem basically is saying that I have like n balloons. So let me take three balloons. I have three balloons, and each balloon have some value associated with it. So I have like let's take 3 here, 5 here, 7 here. Okay, so these are the number of coins associated with the balloons. I can burst any of them. So if I burst this balloon, this is I. So if I burst this balloon, then the cost of then the number of coins that I will get is this value a of I, which is 5, multiplied with the previous value 3 and the next value, which is 7. Okay, so this is the number of coins that I will get, and when I burst this, then these two come together. So now I have 3 and 7 as adjacent balloons. Okay, fine. So the problem is saying that find the maximum possible profit earned after bursting all the balloons. Okay, assume an extra 1 at each boundary. One example is also given here, so let me explain the example. The example is having an array of size 4, and the array is containing values like 3, 1, 5 and 8. Okay, so these are 4 balloons, and each balloon have these much coins associated with them. Okay, fine. Now I can burst any of them, and when I burst the balloon, then I will get value as a of I minus 1 multiplied with a of I multiplied with a of I plus 1. Okay, so if I burst this balloon, then I will have value as 1 into 5 into 8. If I burst this one, then I have the next value as 1, but I don't have any previous value. So this is the boundary problem, and in order to avoid this problem, what I'm going to have is I'm going to take a value 1 and 1 at the starting and end. So this is what the problem says. The problem says that assume extra 1 at each boundary. Okay, now if I burst these balloons, then I have multiple possibilities of like bursting these balloons. So there are multiple orders possible, like 3 1 5 8 is one order, and 3 8 like 3 8 5 and 1 is another order. I have 5 1 3 and 8 is as another order, and there are multiple orders possible. So when I burst like all the balloons in any particular order, then I'm going to have some profit like A, B, C, whatever profit I'm going to have. I have to maximize, I have to return the maximum profit out of all those values. Okay, so there are multiple possibilities for this particular example, but I'm going to give you the possibility which is going to give you the maximum profit. Let's see how. What I can do is, first I can burst this balloon. This is one. So when I burst it, then it is going to give me the cost as, okay, so I want to write cost somewhere. So what I'm going to do is, like, I'm going to remove all these values. Okay, I hope you have noted down those values. And now what I'm going to do is I'm going to write the profit here. So if I burst this balloon, then I will have profit as 3 into 1 into 5. Okay, after that this balloon is now gone. I have balloons as like 1 3 5 and 8 and 1. These one are in the box because of these are just for avoiding the boundary conditions. The original balloons that I have is now 3 5 and 8. Okay, what I can do is I can burst this 5, and when I burst it, then I get my profit as 3 into 5 into 8. Fine. After that, this balloon is also gone. So I have balloons like 1, 3, 8 and 1. Okay. Now I can either burst this or burst this one. So I'm going to burst this 3. When I burst it, then I get my profit as 1 into 1 into 3 into 8. Fine. After that, this is also gone. And I have balloons like 1, 8 and 1. And this is the last balloon that I have. When I burst it, then I get my profit as 1 into 8 into 1. So now all the balloons are gone, and I have only 1 and 1. So these one are just for boundary condition. We are not going to burst them and not going to include the cost due to these. Okay, fine. Now I have this much profit, like this much number of coins that I have. Now how many number of coins are these? I have first of all 15 here. After that I have 15 times 8 is 120. After that I have 24 here. After that I have 8 here. Fine. Now I'm going to add these. So 135 plus 24 plus 8, it is 159 plus 8, and it is going to give me 167. Okay, so 167 is going to be my maximum profit, as you can see in the problem as well. So this is what the problem says. I hope you guys got the clear understanding of the like problem statement. Now what I'm going to do is I'm going to move to the solution. So let me move to the solution now. Okay, before talking about the solution, I'm going to write the array that I have. Okay, so the array that I have is 3158, and I have to burst these balloons, and when I burst two balloons, then these two balloons come together. Then like when I burst this one, then 5 and 3 come together. Actually, this problem reminds me of matrix chain multiplication problem, which is related to the partition DP concept. Partition DP concept. Okay, so now I'm going to divide you guys into two parts. For those who don't know what is matrix chain multiplication, and for those who know what is matrix chain multiplication. So for those who don't know what is matrix chain multiplication problem, just you are good to go, because it is not a prerequisite, and I'm going to give you a detailed explanation about how this problem is going to be solved. But for those who know what is matrix chain multiplication, I'm going to give you a brief about how this problem is related to the matrix chain multiplication, and after that you can go on your IDE and try it down. Okay, let me write. Let me write. First of all, I'm going to write how this problem is related to the matrix chain multiplication. So I have 3158 as my balloons. So if I talk about two matrices, let's say I have one matrix as 3 cross like 3 order. Okay, I have another matrix as, okay, so let me write it as 3 cross 2, and I have another matrix as 2 cross 1 order. So when I multiply these matrices, when I okay, so let's take a 3 cross 1 order and 1 cross 5 order. I have two matrices. Okay, so when I multiply these matrices like A and B, so what happens is these two get eliminated, and the order of new matrix that I will get is 3 into 5. Is there any doubt? No, because in order to multiply two matrices, the like number of columns of first and the number of rows of second must be equal. Okay, so isn't it similar to, like, since this value is getting eliminated, so I can say that this balloon is bursted now, and I have these two balloons together, and this is what the problem is saying. Problem is 315 is there, so I can break it down into like 3 cross 1 and 1 cross 5. So these are two matrices. When I multiply these, then it becomes 3 and 5 comes together, and when I burst this balloon, then again 3 5 comes together. The second observation that I can make is when I multiply a matrix like 3 cross 1 and 1 cross 5 order, what is the cost that I get? The cost that I get is multiply this value, this value, and this value, isn't it? If you know what a matrix chain multiplication is. So it is like AR of I minus 1 and I plus 1. You can even see here. So this is how this problem relates directly to the matrix chain multiplication. And now I hope you guys got the understanding, and now you can try the same solution and the same in order to solve this problem. Now I come to those who don't know what exactly is matrix chain multiplication. So what I'm going to do is I'm going to solve this problem and give you the explanation, intuition, and the approach. And after that, you can try other problems which are based on the partition DP. So what I have is I have like some number of balloons 3, 1, 5, and 8. And what I can do is I can either like keep this balloon and burst all the balloons except this, and at last I will burst this balloon. This is the first way. Okay, what else I can do? The second thing that I can do is I can keep this balloon and I can burst all the balloons except this at maximum cost at maximum cost. So if I have the maximum cost of bursting all the balloons except this, so I can burst this balloon at last, because doesn't matter what order we follow in order to burst the balloon, but we are going to burst any of these balloon at last. So that's what I'm going to do. I'm going to keep any of the balloons out of all the possibilities and burst all the balloons except this, and I'm going to, at the last, I'm going to consider the cost of bursting this. You will say that, hey, stop, whatever you are saying is conceptually easy to understand, but how you're going to achieve this, this is the question. So let me talk about how we are actually going to do something like keep this balloon and burst all the balloons except this, and then just find the cost of bursting this. I will say it let's say f of I and j is the function which is going to ask me that what's the cost of bursting all the balloons from I to j. This is the function. So this function is what? This function is max cost of bursting all balloons from I to j. Fine. Now from I to j, I'm going to consider all the balloons that I have, and I'm going to keep that one balloon and burst all the rest ones, and at last I will burst that balloon. Okay, let's take I'm at this particular index k, and I want to keep this balloon and I want to burst all the rest of the balloons. So how to do it? How to do it? So the cost of doing this, if I write the cost of doing this as my cost, so my cost is going to be equal to, like, okay, let me change the color. So I will say I have to keep it. So I will burst all the balloons before this and I will burst all the balloons after this. Is there any doubt? No, I don't think there should be any doubt, because in order to keep this I have to burst all the balloons except this. So burst all balloons before this and after this. Fine. What is the maximum cost of bursting all the balloons before this? Is something which is given by f of I and k minus 1. Because I is the starting index and k minus 1 is the index, this one. So I have to burst all those balloons and I have to find the maximum cost of bursting all the balloons. So this function gives me the maximum cost. Okay, fine. Now, what is the cost of bursting all the balloons after this one? So this is going to be f of k plus 1 and j, isn't it? So like k plus 1 is index just after this k, and the j is the last index. So from just after the index after this one and the last up to the last, I'm going to burst all the balloons. Okay, now when I burst all the balloons, so I will be left with only one. I will have only this balloon left. So this is kth balloon, and obviously what we are going to do, we are not actually just left with the kth balloon, but we have two more balloons at the start and end, like in order to avoid the boundary condition. So like I have one balloon here of cost 1 and I have one balloon here of cost 1. Why? Because I want to avoid like boundary condition. So if I have like one here, so what is the cost of deleting this one? One previous and one next, but there is no previous and next, so that's why I have one and one written here. Now the cost of bursting this balloon at last is simply going to be ARR of k multiplied with ARR. What is the next element that I have? You tell me. What is the next element that I have? The next element that I have is all these balloons are gone and these balloons are gone. So I have only j plus 1th balloon left. Like this is j, this is also gone. So j plus 1th balloon is something which is not gone. So ARR of j plus 1 is something which is going to be the next, because all these are going to be like gone and I will only be left with j plus 1, and 4 here all the balloons are now gone and I have only left with the I minus 1. So I'm going to write ARR of I minus 1. Now this is the cost which I have in order to like burst all the balloons and keep the case balloon. So now this case something which is going to be start from this I and end at this index j. So from I to j I'm going to find this cost. Like I can find this cost by keeping this 3 as constant, this 1 as constant. Okay, let me write this again. So I have like 3158, 3158. So I can find the cost, this cost by keeping this as like constant, this as same, not busting this, and like keeping this. Okay, so whichever cost is the maximum, I'm simply going to return that. So I have to maximize this particular cost. So in order to achieve that, what I will do is, what I will do, I will simply write for a loop is going to start from k equals to I and k is smaller than equal to j. So I have something which is k and k plus plus. Now I'm going to calculate my cost as this. So my cost is going to be this, and this cost I'm going to maximize. So my answer is going to be max of the answer that I have and the cost that I have. And at the last I'm simply going to return my answer. So this something which looks like an iterative approach. Why? Because I'm calling the function like recursive approach, because I'm calling the same function again and again, isn't it? Now I hope you guys are clear with what I'm actually doing here. So this is the recursive solution, and even if I write the pseudocode for this solution, then the pseudocode is something which is going to be, let me write the pseudocode. I have a function which is f of I and j, there's no doubt. And for this function, one thing is simple, like which is the base case that I'm going to have. Like if I have I and j, if I have array like 3 1 5 8, and my I is at this point, and like my I is at this point and j is at this point, in that case can I start a loop from I to j? Because I is something which is greater than j, so I cannot move from I to j. So in that case I'm going to return, so if my I is greater than j, just return 0, return 0. Fine. And even I is greater than j, which is something representing these conditions. Like if I'm at this particular index or this particular index, or there is nothing to delete burst. Okay, so I'm going to return simple. Now else I'm going to start a loop k equals to I and k is smaller than equal to j and k plus plus. What I can do, I can simply write that cost value. So my cost is going to be like, let's see color. So my cost is going to be f of I and k minus 1 plus f of k plus 1 and j plus simple array of k multiplied by array of j plus 1, because it is left, and array of I minus 1. Simple. And now I am going to calculate my answer as max of answer that I already have and the cost. Okay, fine. And at last I'm going to return my answer. I hope it is clear to you. This is the pseudocode that I'm going to write, and let me even show you the code. So if I show you the code, then this is the recursive code that I have, and you can see this is the Java code and this is the C++ code. Let me write this. So this is the C++ code that I have, and here I have Java code. Now what I'm doing is I'm writing the same condition here. I have taken j as my n, but doesn't matter, the concept remains same, and I'm going to start my b from I, and b is like from I to j. So even let me make it j so that you understand clearly. So what I'm going to write is I'm going to make it j, and you can assume j on the like C++ code as well. So this is something that I'm doing in this problem. At the last I'm maximizing the cost, and I'm returning my maximum cost here. And this is the C++ code. I'm doing the same thing here. And now this is all about recursion. Let's see what else we can do, because this is something which is going to give me a lot of time complexity. So what I'm going to do now is I'm going to draw the recursive tree for this problem. So let me draw the recursive tree. Okay, so here what I'm going to do is I have a problem which is like 3158. Okay, so let me call it function, which is the maximum cost of deleting 3158. Okay, fine. So on which values it is dependent on? The first way that I have is I can keep this value constant. So when I keep this value as constant, then I have to delete all the value before this and all the value after this. So there is no value before this, so I'm going to keep it constant, and 158 is after this. Okay, the second way is keep this value, this balloon as constant. Instead of saying the value, I will say balloons. Okay, so instead of I can keep this balloon at constant and burst all the balloons before and after this. Okay, so I will delete 3 from the left and 58 from the right. Okay, fine. Now the third way that I have is like, for this balloon, they delete all before this and all after this. So I delete 3 1 and I will delete 8. Fine. And after that, the fourth way that I have is like burst 315 from the left and nothing from the right, because I have to keep 8, okay, as my last balloon. Fine. Now for this one, for this is the condition when I have an empty array, so I'm just going to return 0. And even for this single element, I'm going to return like AR of k and I minus j plus 1 and I minus 1. This is a single element case. For this, what I can do is I can keep this one constant. So I have values like 0 like nothing on the left, and okay, so let me remove this. I have values like nothing on the left and 5 8 on the right. The second possibility that I have is keep this 5 constant, so 1 on the left and 8 on the right. Okay, and the third possibility is keep this 8 constant, so I have 1 5 on the left and nothing on the right. Fine. For this 5 8, what I have is I can keep nothing on the left and delete 8 from the right. Okay, and I can keep this 5 as it is till last. Okay, I can even keep this 8, so I will have 5 on the left and nothing on the right. Fine. For this 3 1, what I can do is I can keep nothing on the like I can keep this 3 and nothing on the left will be deleted, and 1 on the from the right is deleted, keeping this one balloon, so I will delete 3 from the left and nothing from the right. Fine. Now for this 315, what I can do is, first possibility is like delete nothing from the left and like burst nothing from the left and 1 5 from the right. Fine. The second is burst 3 from the right and burst 5 from the right and 3 from the left. Okay, for this 5 I can burst 3 1 from the left and I can burst nothing from the right. Fine. So now I'm not going to move further. Instead, what I want you to notice is, if you like, okay, so now I want you to notice something. What that thing is? First thing that you notice is the solution to each problem is dependent on the solution to sub problem. So it is something which is known as the optimal substructure. And the second thing that I want you to notice is, if you see this subproblem and this subproblem, so these are exactly same subproblem. So why to solve these subproblems again and again? This is what I am going to ask from you. After that, if you see this subproblem and this subproblem, these are again exactly same subproblems. If you see this one and this one and this one and this one, these are sub repetitive subproblems. You see this and this, these are again repetitive. If you this 5 8 and if you see this 5 8, so these are again repetitive. This 8 and this 8 is again repetitive. This 3 and this 3 is again repetitive. So we are solving same problems again and again. But why to solve this? This is going to increase my time complexity. So I have something like overlapping subproblems. Now these are the two conditions for dynamic programming. Like if I have some overlapping subproblems, then just store these subproblems somewhere, and whenever you see the same problem again and it is already solved, then just instead of solving again, just return that value. So this approach is known as memoization. So now we have recursive code written and we are just going to apply memoization. This is the intuition, like why I'm like applying the dynamic programming approach. So now I'm going to show you the code for memoization approach. This is the Java code and this is the C++ code. Okay, so let me even write here, this is the C++ code. Now I think it is easy to understand, because in memoization what we do is we have the same like code written here. Code, what I'm doing is I'm creating a DP array first of all, and this DP array is going to be is going to store the solution for the sub problems. And what is the size of this DP array? How to calculate it? Since we have the I which is continuously changing and the j which is changing, so each time I have to consider, I have to store the solution for the particular value of I and j. So what is the maximum value of I that we can have? N plus 2. And what is the maximum value of j that we can have? N plus 2. Why n plus 2? Because we are adding one at the starting and end. Okay, this is not this is something which I have not told you in the recursive approach. Like we are adding one at the starting and one at the end in order to avoid boundary conditions. So now I am storing the solution. You can see here that when I solve any sub problem, then I store the solution in the DP array. And when I see the same sub problem, like here you can see that it is not equal to null, means that I have solved the problems and I have stored the value. So in that case, instead of solving again, I am just going to return that value. Okay, so the same thing I am doing in the C++ code. I hope now it is also clear to you. Now I'm only left with the tabulation approach. So this is the tabulation approach that I have written. Okay, so I don't think it is very hard to understand, because the same concept I'm going to apply here. Like if you see this loop, and if you see like the loop in the recursive approach, you will observe that the same concept is going to be used here. But what the thing is changing is like how I'm starting I and J. This something. Let me give you a brief explanation about how I'm going to start like I and J. So let me erase all this. Let me erase all this. I have a DP array, which is a 2D array. So like 1, 2, 3 up to n, and here 1, 2, 3 up to n. So now what I'm doing is I'm starting a loop from I equals to like k equals to I, and k is smaller than equal to j, and k plus plus. Each time I'm calculating like the solution for I and k plus 1, k plus like I and k minus 1, and k plus 1 and j. If you see the like if you see the tabulation approach, then what I'm doing here, I'm asking from dp I and b minus 1, and I dp of b plus 1 and j. So if like if I start from k equals to 0 to 5, let me write like if I start from k equals to 0 to k is more than 5. So each time I'm asking from the previous row, like previous column, and the next row. So if I'm asking from the next row, you can see here k plus 1 means the next row. So if I'm asking from the next row, then the solution for next row is going to be solved first. So I have to start my row from this in such a way that when I ask from this and k plus 1, like the next row, then solution should be present here. So I'm going to start my I from like here n minus 2. Why I'm saying n minus 2? Because you know that we have added one extra one at the, like if 3158 is present here, so I have added two element extra. So that's why I'm starting from n minus 2. So I'm going to start from the last row, so that each time I will have the solution for k plus 1 row, like the next row. And I need a solution for the previous column. Like if I'm at the this particular cell, so I need solution for this one. So the solution for this column, like J, is need to be solved first. So that's why I'm starting the last row and the first column. You can even observe here that I'm starting from the last row, which is n minus 2, and first column, which is my first column. Okay, now I'm checking the same condition that I have written in my memoization approach, like recursive approach, this one. Why I'm checking this condition? Because I have to start a loop from I to j, right? So if my I is smaller than j, even if I don't write this condition, doesn't going to matter, but this condition is something which is going to avoid all the checks. Like if my I is smaller than j, only then I'm going to start a loop. So this is what this condition says. And now I hope you guys are clear with the like tabulation approach as well. So this is the problem. Like this problem is very much similar to the matrix chain multiplication problem, where I have to maximize the cost of multiplying, and here I have to maximize the number of coins that I can get. So I hope you guys are clear with the intuition approach and how dynamic programming can be applied and everything. So this is all about this problem. Thank you.